Hey guys, welcome back. So in the last video we saw how to do a pre-order traversal of a binary tree. Hope the concept was clear. Now in this video let's see how we can do in-order traversal of a binary tree. So if we remember from our previous slide, that is when we did a pre-order traversal, we were visiting the root first, then the left subtree and then the right subtree. But in case of an in-order traversal, we will first visit the left subtree, then we'll visit root and then we'll visit the right subtree. So let's see if we apply this rule on this binary tree, how will the traversal looks like. So as we can see, the root of this tree is 20. So the algorithm starts from here. Now what is the left subtree of the root? It is this subtree over here. And what is the right subtree of the root? It is this subtree over here. Now how we will do the traversal? Simple. We will put a bracket over here indicating left subtree which is rooted at 100. Then we'll visit root. So we put 20. Then we will put again a bracket indicating right subtree. So we'll again put the root of the right subtree which is 3. So we are done till here. Now let's see how we will evaluate this brackets over here. So this bracket is left subtree having root at 100. So how we'll evaluate that? We will again need a left subtree and root which is 100 and right subtree. So the right subtree's root is 15 which is the left subtree of 100. The left subtree has root at 50. So we'll put 50 over here indicating that the left subtree's root is at 50. Now we have to again solve this bracket over here. So what is this bracket? This is subtree rooted at 50. So how we'll solve? We again put left subtree, then the root which is 50 and then the right subtree. Now since there is no right subtree of 50 because it is null, we can eliminate it. So we will cross it. It's not required. Now what is the left subtree of 50? It is 222. So we'll put 222 over here. So this subtree's work is done. Now we'll come to this subtree having root at 15. Now at 15 we don't have left or right. So we'll only put the root. So we put 15. So this is done. So now 50 is done, 15 is done, 100 is done. So this subtree rooted at 100 is done. Now we'll come to the subtree rooted at 3. Now we have a left subtree which is rooted at 250, which is nothing but this node over here. And then we'll put the root which is 3 and then the right subtree which is 35. Now if we visit 250, then there is no left or right child, it has only root, so we put 250. Similarly for 35, there is no left or right child, so we simply put 35. So 250 is done, 35 is done, so 3 is also done. So this is our final result, that is answer is 222, 50, 100, 15, 20, 250, 3 and 35. So this is the in-order traversal of the above binary tree. Fine. Now let's see what is the algorithm for this traversal looks like. So the algorithm is very similar to the one that we saw in case of pre-order traversal. The only difference is that we are doing this recursive call before printing root's value. Now please pause this video right now and try to traverse this binary tree using this algorithm and this stack memory. It is exactly same as the one that we have learnt in case of pre-order traversal. So please do that now. Fine. So I hope that you have been able to do an in-order traversal using this stack. So now let's see what is the time and space complexity of this algorithm. So comparing if root is equal to null is a constant time operation, returning is a constant time operation, else is a constant time operation. We have a recursive call over here, and this will take t of n by 2 time, assuming that the entire algorithm takes t of n time. Printing a root's value is a constant time operation. Again we have a recursive call which will take t n by 2 time. Now if we apply the back substitution method, we will get time complexity of order of n. Space complexity will also be order of n because it will use an internal stack which will basically push all the nodes of the tree in that stack. So that will take order of n time, where n is the number of nodes in the binary tree. Fine. So I hope you have understood how to do an in-order traversal of a binary tree. Now in the next video, let's see how to do a post-order traversal of a binary tree. Thanks for your time. See you in the next video.